Alrighty, CNT140, we're continuing our Chapter 4 on unshielded twisted pair. So we just got done talking patch panels and patch panel color codes. The next thing they mentioned here is, the patch panels have a lot of cables, so cable management is going to be key. Yes, we need to have some way to organize all the cables we're managing in the closet, so we don't have this. This is a cable management no-no. As I like to say, it kind of evolves into this. You don't plan this kind of thing. It kind of evolves into this over time. And now you have a scenario where if you have to troubleshoot something, good luck finding it, or you're worried about disconnecting something else while you're fixing the problem you're trying to track down. So there is lots of cable management products out there. We have stuff like this in our lab room, these hooks here, these panels here kind of deal, to try to keep our cables managed. And they also do make patch panels that have, equipment racks that have wire management panels vertically on each side as well. So there's all kinds of products out there to help organize, bundle, and protect the cables is what it amounts to. And that is something you kind of engineer in from day one and work on day one. We want to make sure we're avoiding bundling cables too tightly. We preferably want to use the Velcro hook and loop type cable straps, if you will. We want to try to avoid using these plastic ones because to add or remove cables, I need to cut it off and redo it. And the risk of pulling these too tight and damaging the cable is pretty easy. So using the Velcro ones, I can add remove cables easily, and I don't have to worry. There's less of a chance of pulling it too tightly. We'll put it that way. So now into testing unshielded twisted pair cabling. So as we start terminating outlets and patch panels in our room, we're actually going to get testers out and start doing some of the basic tests. Later, we'll get the certification meters out and certify the cable, our cable runs that we installed. So some of this is going to give us a little preview, but also give us some terms and knowledge that we can use later. So we might want to reference back to this later as well. So according to our 568 standard, we need to do things like check the wire map, check the length, and check the performance of cabling after we've put it in. And a certified cable, they talk about the cable itself, the manufacturer needs to test and certify that it's meeting requirements. But we also need to, after we put the cabling in our facility, we will eventually need to test it and certify that it will carry the bandwidth that we're saying it should. Everything we've done, the cable, the connectors, the terminations are all done properly, that it's able to carry the bandwidth we said it should. And that is the kind of thing that a cable certification meter will do. We will do this a little bit later this semester after we've put everything in place and have a cable run in place. We will actually certify to see, is it able to carry the bandwidth we are hoping it will. Verification, on the other hand, is actually hook up a meter that's going to move data across and check for any bit rate errors, if you will. It actually has a verification meter. We don't have one of those. We do have the certification meter we use. We don't have a verification. For us, we're kind of connecting up and using the connection in the lab room. That's kind of our verification. One of the main tests we do is wire mapping. And actually, shortly after we terminate the outlet and patch panel, we hook up a meter to our cable run and run a wire map on it and make sure all the wires in the correct order. In other words, straight through. So our horizontal cabling structure, everything is supposed to be wired straight through. Patch cable here, horizontal cable here, patch cable here. So everything should be wired straight through. So that's what we're going to be looking for. We're going to be looking for, if we're using A, this is our, wire map and our color code, if we will. If we're using B, this is our wire map and our color code. That's what we should be seeing. Again, if I'm using A, this should be my pin out. If I'm using B, this should be my pin out. So when I hook up a cable meter in our system, we should be seeing everything straight through, wired straight through. This would be normal for what we're doing. Anything outside of this for our structure is indicating something's not right, something's not in the correct order, or something is not terminated correctly. So we are expecting this straight through, or you'll see maps like this straight through wiring. Anything outside of that, any of these other things are indicating a particular problem that we will eventually need to locate and solve or re-terminate, if you will. We will spend a bunch of time on this a little bit later this semester. We'll be doing some troubleshooting where I have you hook up faulty cables and identify what is the fault, and then how you would fix it. So this is going to give us some kind of groundwork for later. So super quickly, I could have a wire that is broken, either cut somewhere or not terminated correctly in one of the ends. So it's going to show up that one of those wires is not connected fully. And that is giving us a clue as to what I'm looking for. So I would start looking at each end of my termination and see if I can find it. I could also have a wire short, two wires connected that shouldn't be. Sometimes this happens when you cut the insulation off of a wire. You cut too much, and you actually make little cuts in like the white orange and the white green and the white blue wire kind of thing. And as you go to terminate, those two nicks, those two cuts in the insulation line up and cause a short. I've had that happen when I terminate outlets in an outlet box. And this will show up like so. The two lines that are connecting shouldn't be. On meters like this, you'll see it's very faint over here, but there's a little line showing connection between the white, blue, and the blue wire, letting me know there is a wire short. There is such a thing as a connector open, or where I have one end of my cable run or one end of my cable is not terminated at all. I think it might be, but it's not fully connected at all. The connector might not be on the whole way, or as I terminated the patch panel, maybe I put the punch down tool upside down and cut the wires off before they should have been, into the 110 block. So I can have a situation like this where it's like, hey, there's no cable there at all. That's letting me know one of the ends is not terminated whatsoever. I could also have wires in the incorrect order. I could have what's called a cross pair. Well, cross pair is when two wire pairs are flip-flopped or wired in the wrong spots. This can commonly occur if I do 568B on one end of a cable run, and I do 568A by accident on the other end of the cable run. And that can happen when you do the outlet and patch panel. You're reading the patch panel doing that one B, you get over the outlet for some reason, and your brain goes to A and you wire it up A. Well, when I do that, I've crossed two pairs, the orange and the green, and I'm going to get a cross pair situation like this. It looks just like that if you do one M A and the other one B. That'll be a crossed pair. I've crossed two wire pairs. If I accidentally just flip-flop two wires, white, green, and green, if you will, where it happens usually for me is like white, brown, brown on the end, or white, orange, orange on this end. When I go to terminate into an outlet, that's where it kind of happens to me. That'd be a reverse pair. It's just affecting one pair. And actually, this is the kind of thing that usually pops up for me if I get a reverse pair. I'm sliding it in the outlet or in the modulator pin connector. Those two flip-flop, I don't catch it, I terminate, boom, I now have a reverse pair. The toughest one out of the bunch to diagnose, and luckily our meters help us with this, is a split pair. Well, I have to remember my normal color code order. Here's my normal color code order, especially if I'm dealing with 568B. White, orange, orange, white, green, blue, white, blue, green, white, brown, brown. Remember the four in the middle. We have a pair here, and then the one outside is the other pair. And that was to accommodate phone cabling back in the day. Okay, so that is the color code order that I should be doing. And the meters and devices are expecting these two to be twisted together to cancel. They're expecting the 3 and 6 pin to be twisted together and cancel each other. They're expecting the 4 and 5 pin to be twisted together and canceling each other. And they're expecting 7 and 8 to be twisted together and canceling each other. That's what it's expecting. If I accidentally wire my cable like so, white, orange, orange, white, green, green, white, blue, blue, white, brown, brown. That sounds right. But unfortunately, 1 and 2 are twisted together. That's right. 7 and 8 are twisted together. That's right. But if I look here, 3 and 6, they're expecting 3 and 6 to be twisted together and canceling each other. And they're not. The white, green, and the blue are not a wire pair twisted together canceling each other. So, this white, green, and blue wire, and actually the blue pair and the green pair, are not twisted together correctly canceling each other. So you get a lot of crosstalk in here, so your meter goes, hey, you have so much, I think you might have a split pair. And it actually does, on the meter, indicate here, a split pair has been detected. It's like, hey, I think you have a split pair just by how much, interference I'm seeing on these two wire pairs. Okay, that is a tough one to identify, but luckily our meters help us out with this one. Length test. A lot of our meters now, like the ones I was showing you, or even these, we have these in the lab room, can give you a length measurement on our cable. And after we terminate the patch panel and outlet jacks in our room, we're going to hook these meters up, and it's going to give us an estimate on our cable length. And it's accurate to, again, you'd have to look at the meter. Sometimes it's plus or minus a meter, plus or minus a couple feet. For quick distance checks, this is wonderful, especially after you terminate. You're limited to 90 meters, so if that cable run comes up 63 meters, you're like, oh, golden, we're in good business. This is also helpful when you're troubleshooting. If you know the cable run that you tested is 12 meters, and you come back later because of the problem and you plug it in and it shows up 5 meters, you're like, uh-oh, we have a cut somewhere, let's go find it. It's broken somewhere, it's cut somewhere. This can help you with troubleshooting maybe where the particular problem is as well. That's your length test. Here's another length meter test as well. Some performance testing, attenuation, crosstalk, etc. I need a cable certification meter to do that. And it literally needs to do it over a range of frequencies because of our different categories of cabling. Testing to 100 meg, 250 meg, 600 meg, so forth. So our meters, the meters I get are capable of a certain range of tests. So the meter itself, when you look at the specs on it, is able to certify or test up to a certain category of cabling or a certain frequency of cabling, if you will. One of the first tests we do is attenuation. This is the weakening of a signal over distance. So to do that, I literally need, this meter has two pieces. I hook one end to one part of the meter to one end of the cable run, the other part of the meter to the other cable run. And it literally sends a signal or a series of signals across the cable at a known signal strength and picks up the result over here to be like, hey, we only weakened a little bit, this is awesome. Or if it's too much, it'll let you know, hey, there's too much signal loss, too much attenuation. And that's what attenuation is, loss of signal power over distance. It's measured in decibels. High frequencies attenuate quicker, so we have to watch our cable distances, trying to keep them as short as we can. There's your attenuation, loss of signal over distance measured in decibels. You'll actually hear attenuation referred to more commonly now as insertion loss. This term has in many aspects replaced the term attenuation. So when you look at a meter result, you might see insertion loss, and that basically is your attenuation. And there is a limit by standard of how much attenuation, how much signal loss, how much insertion loss you can have on a cable at your different frequencies. And it just has to be within that range. And I'm using meters like so to test that. And again, we're hooking it up on each end of the cable run. It runs a battery of tests and lets you know what the value was. And as long as it's within range, you're good. And here's a sample result of your test. And these are all different tests that are done, but you would go in here and look for the attenuation or insertion loss. Crosstalk then is, we're looking at how much the signal has potentially jumped from one wire pair to another wire pair. We don't want that happening, but if I have a lot of untwist, I'm opening up the possibility for a signal to jump from one wire pair to the next. So with crosstalk, we're looking at trying to measure or pick up how much of that signal has jumped from pair A to the neighboring pairs. And if I only have a little bit, awesome. If I have a lot, my signal here might be too weak on the other end. So again, there's a range of crosstalk allowed on my frequencies, and as long as it's within range, we're okay. And we really want the signal strength to be strong. The stronger it is, the less it has jumped to another wire pair. So there's one of those, we want this number to be high value. And things like all of our terminations being sloppy, too much untwist, etc., patch panel, outlet jack, patch cables, is going to increase the possibility of crosstalk. And here I show you a half-inch untwist, that's our max. And here's some examples of, oh, look at all that wire, look at all that untwist. Look at all that wire, look at all that untwist. Okay, look at all that wire, look at all that untwist. These would be reasons for potential crosstalk issues in your cable system. We'll come back and talk more testing.